Assalamu alaikum. This is me, Dr. Saifullah, and I welcome you to the new video about financial modeling using Microsoft Excel. Again, in this video, we will talk about time value of money, that is an important topic in finance and financial modeling. In earlier video, lecture 8, we have talked about the calculation of future value of lump sum amount and annuity. The link of that video is shown in the upper right corner of your screen, as well as placed in the description of this video. In this video, we will talk about calculating number of years and payments in case of lump sum amount and annuity. We will be calculating number of years for lump sum amount, number of years for annuity, and payments in case of annuity. Firstly, we will calculate the things manually, and later on we will use Microsoft Excel function to calculate the future values. Number of years of lump sum amount. Sometimes you may know how much money you have today and how much money will need in the future. If you know the interest rate, you can solve for n to find the time it will take for the present value to increase to the future value. For example, consider a following scenario. You now have $1,500 and you want to know how long it will take you to grow that money to $2,500. Assume that you will be able to earn 9% on your investment per year. We will use this formula to calculate the number of years. N is equal to log of future value divided by present value divided by log into 1 plus I, where I is interest rate, FV is the future value, PV is the present value, and N is the number of years. In this example, we have present value of $1,500, future value is $2,500, annual rate of interest is 9%, and we have to calculate the number of years. If we use the formula, then N will be equal to, start the parenthesis, log of future value divided by present value, close the parenthesis, divided by, start the parenthesis, log of 1 plus I, close the parenthesis, and press enter. We can find the number of years that will be required to grow your amount from $1,500 to $2,500 at 9%. It will be 5.9275 years to grow your amount from $1,500 to $2,500. Instead of applying this calculation by using formula, we can use Microsoft Excel function to calculate this easily. To calculate this by using Microsoft Excel, equal to NPR. NPER basically returns the number of periods for an investment based on periodic constant payments and a constant interest rate. Start the parenthesis, rate is 9%, comma, payment 0 as we have no payments. Present value, we will press minus sign with the present value as it is initial investment, that is an outflow. So we will use minus sign with this present value, comma, and future value 2,500. Close the parenthesis, press enter. So we have got the same answer that we have computed with the formula. So Microsoft Excel performs this calculation very easily. If we repeat the process, we will use NPER function, that is equal to NPER, start the parenthesis, rate, comma, PMT, comma, present value, comma, future value, and close the parenthesis. We will get the answer, that is 5.927, and by formula text we can get the formula that we have placed here. So these are the formulas that we have used to calculate the number of years for lump sum amount. The second is number of years of an annuity. We can find the number of years of an annuity if the future value of the annuity is provided. And the example is, let's assume that a person saves an additional $2,000 each year. Assume this person wants to know how long it will take to save $18,600 by saving $2,000 every year. Every year, the saving will receive 5% interest. The formula that we can use is little bit different. N is equal to log of 1 plus future value into I divided by cash flow divided by log of 1 plus I. FV is the future value, CF is the cash flows, I is the interest rate, and N is the number of years that we are going to compute. So according to example, $2,000 is periodic payment that we will made in each year. 18,600 is the future value, 5% is the interest rate. So according to example, $2,000 is the periodic payment that we will made. 18,600 is the future value and 5% is the interest rate. Firstly, by using formula equal to start the parenthesis log of start the parenthesis 1 plus start the parenthesis FV into interest rate divided by cash flow divided by start the parenthesis log of 1 plus I close the parenthesis and press enter. The answer is computed, that is 7.82 years. We will perform the same calculation by using Microsoft Excel function, that is equal to NPER start the parenthesis rate is 5% comma periodic payment, that is an outflow, so we will press negative sign with this 2000 comma present value is 0 comma future value 18,600 comma that's an ordinary annuity and where payments are made at the end of the period, so 0 close the parenthesis and press enter. So we will get the same answer, that is 7.826 years to increase your amount to 18,600 if you deposit 2,000 each year and earn 5% interest rate. Similarly, we can also find the number of years of an annuity if the present value of the annuity is provided. Let's have a look at an example. An individual received $15,000 today. He is attempting to calculate how many payments would be required if he wants to return this loan. He can only save $4,000 a year and relevant interest rate is 6%. That's the formula that we can use to calculate the present value, that we can find the number of years in case we have provided the cash flows and the present value. N is equal to log of 1 minus present value into I divided by cash flow raised to power minus 1 divided by 1 plus I. CF is the cash flow, PV is the present value, I is the interest rate and N is the number of years. So we have 4,000 periodic payments, that is the saving of the person. PV is the present value and interest rate is 6%, and we have to find the number of years. The future value is 0 and same payments are made at the end of the year. Number of years is equal to start the parenthesis log of start the parenthesis 1 minus start the parenthesis present value into interest rate divided by cash flows close the parenthesis raised to power minus 1 close the parenthesis divided by log of 1 plus interest rate close the parenthesis and press enter. The N is computed, that is 4.37 years to complete 15,000 if you can save 4,000 each year and earn 6% interest rate on your savings. Similarly, by using Microsoft Excel function, we can compute this easily. Equal to NPER start the parenthesis rate is 6% comma minus 4,000, that is payments comma the present value 15,000 comma future value, that is 0 comma the payments are made at the end of the year close the parenthesis press enter. So we have the same answer 4.37, that will be the time required to increase your amount to 15,000 if you can save 4,000 each year and interest rate is 6%. In the next section, we will talk about the payments of an annuity. An annuity is a series of payments made at regular intervals and we can find the payments required in case of annuity if the future value of the annuity is provided. Let's suppose that an individual wants to have $12,000 in his account after 5 years. The account balance will earn interest rate of 6% per year. How much money will he needed to save per year to reach his desired balance? That is the formula that we can use to find the cash flows in case of annuity and if we have provided the future value and the interest rate. CF, cash flow, is equal to future value into I divided by 1 plus I raised to power n minus 1. CF is the cash flow, I is the interest rate, FV is the future value, and n is the number of years. So we have 6% interest rate, number of years 5, and 12,000 is the future value. By using formula equal to start the parenthesis, future value 12,000 multiply by interest rate divided by start the parenthesis 1 plus I close the parenthesis raised to power n close the parenthesis minus 1 close the parenthesis and press enter. The answer is computed, that is 2128.76. That payment is required if you want to have $12,000 in your account for after 5 years. And by using Microsoft Excel function equal to payments PMT, start the parenthesis, rate is 6%, comma, number of years are 5, comma, present value is 0, comma, 12,000 is the future value, comma, type is 0, close the parenthesis, place negative sign as the payments is an outflow and Microsoft Excel provide answer in negative form. So we will place minus sign before the formula to bring this into positive form, that is $2,128.76. We can also find the payments of an annuity if the present value is given. For example, an individual received $18,000 today. He is planning to return this loan in 3 years. The applicable interest rate is 5%. How much he should pay to completely offset this loan? This is the formula that we will use to calculate the cash flow. Present value into interest rate divided by 1 minus 1 plus I raised to power minus n. CF is the cash flow, I is the interest rate, PV is the present value. In the same example, we have 5% interest rate, 3 is the number of years, 18,000 is the present value. So by using formula equal to start the parenthesis, present value into interest rate, close the parenthesis, divided by 1 minus start the parenthesis 1 plus interest rate, close the parenthesis raised to power minus n, close the parenthesis and press enter. So the answer is computed, 6,609 is required if you want to fully return this loan. By using Microsoft Excel function, we can calculate PMT. Start the parenthesis, rate is 5%, comma, NPER 3, comma, 18,000 is the payments, and we will press minus sign, close the parenthesis, press enter. So the payments is computed, that is 6,609. That's about the calculation of number of years and payments in case of lump sum amount and the annuity. In the next video, we will talk about calculating annual rate of interest and its related calculations. If you have any questions related to finance and financial modeling, you can contact us. We will try our best to provide you best answers. Thank you. Take care. Allah Hafiz.